All right. Okay, everybody, we're going live. And we still don't have host privileges. Still can't do it, Carmen. But we're live. Okay, so YouTube people, our technical people are working on it. And as soon as they give us, oh, yay, now we're the host. Good deal. All right, everybody. We are going to enjoy some weather and weather information. So if you could, feel free to unmute yourself because we want to have some interaction. And if you can also show yourself on the screen, start your camera, that also makes it a little bit more interesting. So, all right. Hey, Joshua. Hey, Jonathan. So we're going to start with a word of prayer. Do we have any volunteers that want to pray for us? All right. Do you want to pray?
Heavenly Father, we come to you with thanks in our heart for the many blessings you have given us, most especially the Sabbath day. We ask you to be with us. Send the Holy Spirit to dwell with us as we see weather as it's presented by you, Father, in its awesome strength and exciting ways. But Father, keep in mind that we have to have the Holy Spirit here showing us the way that we can walk in Jesus' steps. Thank you, guide us and be with us in Jesus' name, amen.
Amen. So we're going to start the weather honor. You guys are going to need some paper and pencils and your Bible. And we are going to start. This is what the honor actually looks like. But if you look at the old manuals, this is actually upside down. So when you put it on your sash, you might want to turn it the other way because as a weather instrument, this is called a weather vane or a wind vane. And this opening at the top would probably be, it could end up being a rain gauge. So it's actually upside down. So that is more like the way it should be right there. And we are going to continue.
If you'll continue.
Sure.
My glasses are a mess.
So what's the point of weather forecasting and why do we care? What do you guys think? You can unmute yourselves.
It gives people the ahead of time to know when something is coming, like rain.
Well, yeah, like when we're going camping. Do we need to take a poncho or a parka? Do we need to go shorts or flannels? All that sort of thing. You guys never go camping in the rain, right? It never rains when you go camping. Really? It always rained when I went camping. In fact, when you wanted it to rain.
It always rains unexpectedly. So we always think it's not going to rain, but it rains.
Yep, that's the way it goes. So are we going to be able to enjoy the camping trip or is it going to rain all weekend? Who are we kidding? We're Pathfinders and it always rains when we go camping, right, Carmen? It always rained when you went camping, didn't it? Oh, yeah. So is weather forecasting new? Nope, it's not new. Do you guys have your Bible? Okay, let's look up Matthew 16, verse 2. Matthew 16, verse 2. So when you're ready and you find it, you can go ahead and read it.
You said Matthew 16, verse 2?
Uh-huh. Matthew 16, verse 2.
He replied, when evening comes, you say, it will be fair weather, for the sky is red. And in the morning, oh, wait, it was just 2, right?
Uh-huh.
Yeah.
So isn't that kind of cool? The Bible even talks about forecasting the weather. You can look at the sky, and if it's night and it's red at the sunset, it's going to be fair weather. Is there an old adage or something that goes something along those lines?
Yes. An old sailor's saying was, red in the morning, sailors take warning. Red at night, Sailor's Delight. That was a little backwards of this.
Yeah, but it still is the same thing. All right. So we know that analog, it's recognizing a pattern. So like red skies. But what do you think persistence is? Did you guys hear the Friday night talk? Were you guys on Friday night?
Yes.
So do you remember how the pastor said that Jose kept calling and calling and calling and calling and calling him, and that Jose was quite persistent?
Which means he was
So
like
persistence,
determined.
yeah, right, like stalking him almost. So persistence is you look at the pattern, what's it been like? And so if it's been like that, it's probably going to continue being like that. What about trends?
The way like weather moves.
Yeah. So like in October, you know, it's probably going to start getting cooler. In May, it's probably going to be hot, very hot. So the trends, how's it always been? That sort of thing. So let's look at a map in a little bit, and we'll see if we can figure out the forecast in that. So trends can be like if it's raining in Cocoa Beach right now and the wind's blowing from the east. So Cocoa Beach, where's Cocoa Beach?
Isn't that like Sarasota?
Oh, opposite side of the state. Nice guess though, very good guess. So Cocoa Beach is going to be on the Atlantic side. And if it's raining in Cocoa Beach and the wind's blowing from the east, coming towards the west, what's going to happen in Orlando to Carmen in a couple hours?
It's gonna rain.
Yeah, so it's raining here. The wind's going to push that rain, and poor Carmen's going to get rained out in a little bit. So let's see what we can do. And numerical weather predictions, that's another way where the computers figure everything out. So here we go. Here's our map. And this was at 2:35. This is at 4:02. And see all those little arrows? Those arrows are showing the wind direction. So can you see how it's pushed the rain? It's pushed it south and also to the east. That's how they use the forecast and the predictions. So going back, what's climatology? What do you guys think it is?
The study of climate.
Sure. So they look at hundreds of years and they see how it's gone for hundreds of years. So it's a longer duration where they figure it out. So it's not like the world's going to end because we're all going to die of global warming. We're not going to talk about that. That's a different kind of category. But climatology is where it takes it over a long period of time. And numerical weather predictions, it takes the current data from all over the world, different stations, and it runs it through supercomputers, and they spit out the forecast. But none of these are really always completely reliable, right? They're never always 100% right.
Now let's kick it back on over to John Billows for our 5-day weather forecast. John. Thank you, Tim. Well, not a lot of surprises this week. We're going to have some highs in the mid to upper 70s, and things are going to cool down to about 50 degrees or so each night. So not quite swimming season just yet, but we're getting there. Let's take a look at the nation. We've been tracking a small cold front that's been moving in from the northwest here. So, okay, it sounds as though the cold front has expanded in size, and you can see that here. Okay, and it looks like it's continuing to grow. Look at that. Okay, if we jump back to our 5-day forecast, we're going to see a few changes. Expect highs in the upper 40s with lows down to 20 degrees or so each night. I want to break out the heavy blankets again this week. If we come back to, wow, okay, it looks like the cold front has really gained some momentum here, and it appears that a storm has started to gather as well, but fortunately it doesn't look too serious. Okay, it's actually becoming a little serious. It seems that hail is starting to fall, about 1 millimeter in diameter. Okay, it seems our initial estimate was a little off. They're more the size of basketballs. Pieces of ice the size of basketballs are falling from the sky, so that is pretty serious. Everyone should probably be taking refuge under concrete structures just as fast as humanly possible. Let's see how this will affect the 5-day forecast. Highs will now be in the upper 10s with lows in the negative 20s, and if you look on Tuesday, there's a slight chance of death. Let's go back to the map here, and oh my. Okay, it seems that the storm and the cold front have clashed violently, and we now have a flood warning and a fire warning. Look at that. I'm not sure how those two can be happening at the same time. Okay, it appears that the flood water is the thing that is actually on fire. Apparently, the flood destroyed 15 gas stations, so about half the flood is now comprised of gasoline and oil. The fire and the flood are traveling together at untold speeds, so we encourage everyone in the area to quickly move to higher ground. Nope, cancel that. We've just been instructed to tell everyone to evacuate to Mexico. Nope, never mind. They're coming here. We're heading to Canada. Okay, if we jump back to our 5-day forecast. Okay, scratch that. Mother's love. Okay, the flood fire, which we are now referring to as the flyer, has destroyed several cities. And okay, it sounds like an earthquake has started as well. That is unfortunate timing. We're getting word now that, okay, yes, it's been confirmed that California has broken off of the United States and is starting to float away. Okay, quick update on the hail situation. Good news. The ice particles have shrunk down now to the size of baseballs. Oh, never mind. They are now enormous Volkswagen Beetle-sized pieces of ice, and they are covered in long spikes. So, oh my, looks like we have a tornado. No, 17 tornadoes, which are now hurling the car-sized spike balls at 85 miles an hour in every direction. Okay, we have received word now that volcanoes are erupting. So let's look at the 5-day forecast, and we'll see the temperatures are still fluctuating, but the chances of death have stabilized at about 99.99%. So going back to the map here, sweet glory. The tornadoes have made it so that it is literally raining cats and dogs, and California is starting to sink, and the inhabitants are being attacked by sharks. Okay, we have confirmation that this is the end of the world. So we'll go once more to our 5-day forecast, which is now our 1-day forecast, and that will about wrap it up. Back to you, Tim.
So how often do meteorologists get it right?
Rare.
Okay, so it may not be that bad. But Jonathan, how'd you like the sharks, huh?
I don't know.
Don't know. So we're going to talk about weather instruments. What is this weather instrument? Do you know what it's called?
A weather vane.
What does it measure? Any idea?
Wasn't it the speed of the wind?
Actually, not quite the speed. That's going to be something else. That's a very good guess.
The direction?
The direction. So the arrow is actually going to point in the direction the wind is blowing. So one of the requirements is for you to make a weather instrument. If you want to make a weather vane or a wind vane, that's your prerogative. Any of the weather instruments you want to make, it's totally up to you, but you can have a lot of fun doing it. So it's going to measure the wind direction. Yes, sir.
Wind direction from.
Oh, from, yes. So the wind's blowing from the west.
That's correct.
Yes, the wind's blowing from the west in this one. Sorry if I misled. So that's the wind vane. What do you think this is? Whoops, sorry. Well, now what do you think this is? This is a hard word to say. It's called an anemometer. Oh, sorry, anemometer. Anemometer. And this is what actually measures the wind speed. So here is how it works.
So how do we measure wind speed? Maybe not as easy as you might think. We use this device right here called a cup anemometer, and named rightfully so because of the cups that are around the frame here of this anemometer. There's a 4-cup anemometer like we have here, and there's also a 3-cup anemometer, both used for different things, but basically get the same result. And they're great because they can measure the speed of the wind regardless of what direction it's coming from. That wind speed is caught up in the concave side of the cup there in the anemometer. So when the wind begins to blow, it will spin the anemometer. So how does that work? Well, a little math for you this morning. I know it's early, 5:26. right now. But if we find the circumference of the anemometer, which we'll call C, and you are able to count, which is all done by a computer within the anemometer itself, if you count the number of rotations that occur within a minute, and then you multiply that by the circumference, you're able to get, if you measure it in inches, the inches that it goes every minute, you're able to then calculate that to be the miles per hour that the wind is blowing this question.
So that's a lot of math, or it sounds like a lot of math, but basically it's like this. You can follow the anemometer as it spins around. So if you can really see all the cups distinctly, it's going between 1 and 5 miles an hour. So if it's harder to distinguish the cups, then it's going a little bit faster, between 5 and 10. But if it's spinning and it looks like a blurred donut, how fast do you think it's going?
Like 100 to 150 miles per hour.
No, it could be, but the slowest it would be going for it to blur would be 10 miles an hour or more. So it could go into hundreds of miles an hour. So it could easily.
Have you ever seen a windsock at an airport? Same thing pertains to that. If it's hanging halfway down, that's about 5. Straight out, that's about 10.
So you can see why they use the computers. It makes it so much easier for it to count everything. So let's see. What is this instrument?
A thermometer.
It's a thermometer. Can you take over? I gotta.
Yes. How does a thermometer work? Basically, what it does is this thermometer is a alcohol thermometer with a color in it, red. And as it heats up, the alcohol expands and it just climbs right up that tube. And it tells you what the temperature is. It measures the temperature. You also have thermometers that work on a spring. You also have thermometers that are mercury, and the mercury work exactly the same as the as your alcohol thermometers, according to the expansion.
Arrow button. Arrow button. Yeah. Arrow button.
I'm sorry, I got a little lost there.
The right direction. The right arrow, yeah.
Okay. There's a mercury thermometer. Now, remember, if you do have a mercury thermometer, it breaks. Mercury is not a good metal. You don't want to play with it. Everybody likes to play with it because it is a liquid metal, but it can get into your skin and it can do you harm.
What's wrong?
This is the spring type thermometer. You've seen these out in the backyard and all. This one happens to have both Fahrenheit and centigrade, which a lot of thermometers do have the Fahrenheit, and they call it centigrade. In my day, I was raised calling it centigrade, but it's called Celsius now. So it's the Celsius, or they both the C and an F. This is how a thermometer works with your with the spring. They're the easiest ones to make and the safest ones to have around because they're not glass. The spring will expand and contract according to temperature, and it's a combination. It's what they call a bimetal, which is both brass and steel. And if it expands, if it gets hot, the steel expands and the brass expands, metal expands, and that moves the arrow. Anybody know what this one's called? Don't look at the bottom of the circle. Any guesses here?
Barometer.
Hey, how did you guess that? That was quick. A barometer measures the weight of the air above it. And When you have a low pressure area, it's this, the measurement goes down, and when you have a high pressure area, a lot more air, it goes up. And you have ways of telling the weather by the barometer. You ever hear on the weather forecast, they'll say a low's coming in. That means a low pressure area, according to the barometer. When it's a low pressure area, you're starting to get into change of weather, rain, stormy when it gets lower. And over here behind where your pictures are, you can have the change of weather, and then you get clear, and it gets very clear and dry. So that's how the barometer works. They always give you the barometric pressure of hurricanes. And the reason they do that is because you can tell really how intense the hurricane is by how low the number is. It gets way down. I was flying once in Boston. Well, I flew a lot in Boston, but this one particular time, it was toward the end of the hurricane season. There was a hurricane that came up north. And I asked the guys that were giving me the barometer setting for my airplane, and that's called an altimeter setting. And I said, golly, that's a low one, isn't it? They said, yeah, that's the lowest they've seen.
Can I have the balloon, please? Do you guys have a balloon? Do you have a balloon? Did they tell you to get a balloon at all?
No, but I can go get one. I have one here.
Like, go ahead, Dad.
Okay, so you're talking about barometric pressure. That's the measurement of the weight of the air above. So
if this is you, and this is the air surrounding us, if it has a low pressure, it's pushed in like this, and see how there's less air above you, and there's more air over here. So the more air that's above you or on top of you, the higher the pressure is going to be. Okay, so hot air rises. Think of a hot air column. There's going to be a whole bunch of air above. So looking at sunny, 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 where on this barometer do you think it's going to be? I'll be back again. Sorry.
that's going to be a low or a high pressure area because there's a lot of air above us, but it does give us a sunny or a clear type day, and the more pressure, the clearer it seems to get. There's you also have your air moves upward in areas that are dry, around deserts and all that. So you have a situation where if it's really, really hot and dry, you start getting into a drought situation. So that's what you're dealing with there. This is a change of weather, which is changed to rain, stormy, rain, stormy. So you have a different situation with the other side of the barometer. Are we okay so far, gang? Everybody understanding? Okay.
Yes.
This is slightly different in that we're talking hurricane here now, and a hurricane is a very, very, very low pressure area. And you have to remember that a hurricane has bands around it that are wind, and the stronger the wind, usually it gets very strong in the center, and it gets less as it goes out. And also the weight of the air becomes greater as it gets further out because it's getting away from the low pressure area. Do you know what this is called? Take a wild guess. What do you think it would measure?
A water a water gauge, I think. I don't know. I thought that's what it was.
It's going to, that's right. It's a rain gauge. It's going to measure the amount of water. Now, if you look at the top, see how big around the top is and how small the tube is here? They do that so that you can bring all the water into one spot and into this narrow tube, and the narrow tube will give you the measurement. If it was straight down into this wide or large mouth and cylinder type thing, you would have difficulty measuring the amount of rain. But since you condense it into a smaller tube, you can read how much it's been raining. Make sense? Now here you can see it. Now then, once this fills up, and I think we have one that's full here in just a second, the rain gauge. Oh, I'm going back one. And when you get into a rain gauge like this, once the tube fills up, it overflows and comes into this larger tube, which will then tell you the additional amount. This may hold, say, an inch or two, and this is going to hold a lot more. So it will tell you this is the first inch, and then after that, it's in inches out here. So that's the way the rain gauge will work. Radar. Oh boy. Y'all remember how radar looks on the TV, right? They'll show you pictures of the storms. They'll show you pictures of weather fronts, and weather fronts are usually associated with the low pressure areas, and radar can give you, you see it going in a circle, and you'll see it from a particular point. Like Orlando may have a weather radar going from their tower. Tampa would have one going from their tower, and West Palm Beach or Miami from their tower. And it shows you the location and the intensity. The old weather radars just showed you that there was a weather front there and weather was coming in. But the newer ones, they will show you not only the weather, the front, it will show you the intensity, and it will show you where they think that there's going to be a tornado or something along those lines. They call that Doppler weather, Doppler radar. And any questions about the radar? You guys know about the radar. You see it all the time on the weather at night. And they'll say everything's clear because they don't see anything on the radar. Satellites. A lot of the satellites are what's used when they're dealing with the larger air masses. Well, face it, we got the hurricanes. We always look for the weather reports coming from the satellite on the hurricanes, so we know where it is and which direction it's moving and how fast it's moving and how intense it is. And you can literally look down on the hurricanes and you can see, sometimes they'll say, you can distinctly see the eye. That's the center of the hurricane. But if you don't see it, then the hurricane's not as intense. But the more definite the definition of the eye is, you know how much it's much stronger, because that eye is really something. How would you like to be a pilot flying an airplane into those, right? You think that would be fun? That would be in the old days at Disney World, we used to call that an e-ticket. That was the best ticket ride you could get. That's satellites looking at things. Then you have computers. What do the computers do? They get all this information and they tie it together. They can do all of the above stuff that we have just been discussing. one of the things that they used to do in the old days was they would look at what the weather was like and what the patterns were like 2 or 3 or 4 summers ago, so they could tell what the winter was going to be like this year. And when they found one that was similar, then they would predict the weather to be similar to what it was in, say, 1895, because they had no other way of doing it. Now we have computers doing that. They will evaluate all the temperatures and all the wind directions and all the wind speeds, and they will give us a lot better information. However, it is still one of those things where it can change. So you always have to remember that it can change. Here's one out of Melbourne. Radar, see it? You have the up north, you have the storm. You have the other storms that are over the landmass of Florida, but that gives you a complete circle view of what's going on around Melbourne. And sometimes, keep in mind, sometimes what they get real close to metropolitan areas, they call it, you will get actually reflections off of buildings and so on and so forth. And that's, they'll always warn you about that. But that's weather radar right there. There's a satellite. That's a satellite view of a storm. I don't know which storm this was, but it's going up through the Panhandle and the Big Bend area and all. So you can see how it's moving and how big everything is. And which side of the hurricane is the worst weather and the most weather? Can you tell by looking
The
at
outer bands?
what's that?
The outer bands?
The outer bands, but which side of that hurricane? The north, the east, the south, or the west? Where would be your most intense weather?
The northeast.
Northeast, that's right. You can see up into the northeast, you can see a definite definition of stuff that's really happening. And down in here, it's building, and over there, it's a little bit weaker because it's gone over the landmass.
These kind of satellites, they can see all kinds of things from clouds. You can see the clouds. You can see dust storms from Africa. You can see pollution. You can see the aurora borealis. You can see all kinds of things. And they're one of the most common forms of satellite weather instruments and notation that they use. What do you guys think this is called?
And don't get the meatballs mixed up with it.
Spaghetti model?
Yes, sir. Spaghetti model. Why on earth would anybody call that a spaghetti model?
Look at all
It
those
looks like
lines.
spaghetti.
Looks like wiggly. Wanting to take out spaghetti.
It does.
Did you ever think of eating spaghetti that was green or yellow, or well, it's all yellow, red, blue? Those are all different forecasting systems that forecast what the storms are going to do. And they're all using basically the same data, coming up with different ideas of how it's going to react.
So here's one. Go ahead. What do you guys think about that one?
My gosh.
And if you look over in the bottom right part of your screen, there's one model that's even saying that the hurricane is going to create a nice little heart around us. Do you see the yellow heart?
Yes.
Yeah.
Isn't that cool? Okay.
Wind. We all know an old man that has a lot of wind, right? Really talks a long time and too much. Well, this happens to be the natural wind, although that naturally comes out of his lungs. But we have all kinds of wind. One is convection wind. Anybody know what a convection wind might be?
When we go camping and you light the fire, where do the little sparks go?
Into the air.
They go up into the air. If you light a candle and put your hand over it, can you feel the wind going up or the heat rising?
Yeah, you
So
feel the heat rise.
Yeah, so heat rises. And if the heat's going up, where do you think the cold air goes?
Down.
So the cold air gets pushed over and then comes down to fill that empty void. So it creates this kind of pattern. Let's see another. So see how the heat is rising, going up, and the cold air is coming in to try and replace it, because nature doesn't like a vacuum. So it's going to try to create this circular effect. How do you think that's going to affect our weather patterns? Well, let's go look. What do you think's going on here? What's going to be hotter, the deserty air, the desert type land, or the mountains? What's going to be hotter?
The desert.
So which way is the air going to go up? Which way is the air going to go up? Which way is the air going to go, up or down?
Up.
So it is going to rise up. And the cooler mountains, the air from the cooler mountains is going to try and fill that void that was left from the hot air rising. So which way is can you see how it's also affecting the wind direction? The wind direction, it's going up from the desert side of things, and it's cooling off and coming over to the side. So this is creating a wind to the mountains. So that's kind of how that goes. And which brings us to our barometric barometer again. So notice the air pressure gradient. So look at our barometer and look at the air pressure gradient. So the cool surface in the mountains, is that going to have a lower barometric pressure or a higher barometric pressure?
Higher because it's above us?
That's a good thought, but actually, remember, cold air, there's less cold air above you, so there would be less weight pushing down on you, so it would be a lower. So if you look over here, when it's stormy and rainy, is it hot or cold?
Cold.
It's usually cold. So if you look, stormy is 90 or 950 millibars. When it starts to get a little less stormy, it's 960 and 970. It changes like that. When it's just rainy weather's like 970 millibars or 980. As it gets hotter and fairer, hot air rises, creates more air above you, which weighs more. Even though we don't feel the weight of the air, it does weigh. So if it's a sunny day at the beach, where on this barometer do you think it's going to be? What do you think the barometric pressure is going to be? Can you see these numbers? They're kind of small. So if stormy's over here at 950, rainy's over here at 980, right in the middle is going to be about 1,000. That's going to be where it's changing. Either it's getting rainier or it's getting clearer. Fair over here is at 1,020. And the desert's going to be like 1,040. So where do you think the barometric pressure would be if it's a nice sunny day at the beach?
1,020.
Good guess. Great. Fair skies. I like it. So go ahead.
The barometer measures only the weight of the air above it. Always keep in mind that it's no different than a scale. It's a scale that weighs the air. Just like a scale weighs you, it weighs only what's above it. It doesn't weigh anything else. And that's what the barometer weighs, the air above that barometer at the time.
So it's pushing down on that mercury, and the mercury in the tube has nowhere else to go but which direction?
Down.
Up. So if it's pushing down on the cup with the mercury, there's a little column. So that column is going to get higher and higher and higher and higher and higher. So that's how you get a higher rating on the barometric pressure. There's another example of what it looks like, where it's actually pushing on a vacuum chamber. So instead of pushing down on mercury, it's pushing on this empty container, this vacuum container, and that adjusts and moves the little springs inside.
That's basically the way altimeter in an airplane works too.
And so convection, that also determines the wind direction. So look at this. Have you noticed at the beach at night, which way does the wind blow?
Yeah.
So have you noticed at nighttime, the wind blows from the land to the water, but when you're at the beach during the day, it blows from the water to the land? It's because of this convection. So what's going to be hotter, the land or the water during the day?
The land?
Yep, the land's going to be hotter. So the hot air is going to rise and it's going to move over towards the ocean, and the cooler ocean's going to be rushing in. The wind from the ocean being cooled by the ocean is going to rush in to try and create that circular convection. So that's why that happens, where you get the wind from the ocean. But at night, the land cools faster, so now it becomes cooler and the wind changes directions. So that's going to also affect wind patterns around the world. And something called, have you guys heard of the jet stream?
Sometimes, yeah.
If you look at this closely, you'll see red and you'll see blue and you'll see white, and the arrows keep going in one direction, so to speak. That's because of it's a prevailing wind for that part of the world. Sailors picked up on this having prevailing wind, so they would sail a certain latitude and longitude. They would sail, get in those, and then they would head east for in one area, and then they would change their route and head west in another area. So that's prevailing wind. But back to the jet stream. So
here is a computer generated model of wind convection. And you can see how the sailors, like Dad was mentioning, how the sailors could utilize the wind to fill the masts and the sails. So jet streams. This is the jet stream. That convection creates this tube that you can't see, but you can feel, and airplanes take advantage of this.
Airplanes will. They actually will fly in the jet stream to pick up speed, and they will actually get away from the jet stream. If it's on their route, they will request another route around it. Otherwise, they've got a major headwind at that altitude and that particular longitude.
So here are more examples of jet streams. So it's not just one. So like he said, they would request a different flight pattern to get out of that specific trade wind. There's the northeast trade winds, the westerlies, the easterlies, and sailors utilize this information, pilots utilize this information, and now you can kind of see. But have you ever thought that wind was like a column or a tube around the world? Here's another computer generated model, and you can see how it moves based on different fronts that it's interacting with, high pressure areas, low pressure areas. And you can see how that warm, high pressure area is affecting the jet stream. Did you see how it was moving? That cold front is pushing it down. That warm front is pushing it up.
They have on record a gentleman who was flying from Texas to Florida, and he had his flight plan laid out, and he was supposed to be cruising at about 120, and one of the very rare times that the jet stream went down, and he was flying at 9,500 feet, and his speed across the ground was in excess of 300 miles an hour with an airplane that normally goes 120. So he's covering a lot of territory, and he calls these people to get a radar fix on him because things aren't looking normal so far as what he thought he was going to see. And he was way, way, way to the east of where he thought he was. But he was cruising along, and he got what they call a ground speed, and his ground speed was like 320 or 340 mile an hour. In a Cessna, it goes 120.
So again, here are some more examples of jet streams: subtropical jet streams, polar jet streams, all kinds of jet streams. So mountains, we kind of touched on that. Mountains affect the wind and the weather, right? So here's an example. What do you think is going on in this example, in this picture? How is the mountain affecting the weather? How is it changing it?
It doesn't let the rain go to the other side.
Yeah, so it's gonna see how it's lush and green trees on one side, but like dry nothing on the other side. Just like you said, Jonathan, it couldn't get over the top of the mountain. So the mountains also affect the weather. Local rain patterns. Here's a picture of Florida. When do we usually have rain? It usually rains in the afternoon.
For us.
For us.
Sometimes
But-
at night as well.
Yeah. So you have that, and they always joke, if you don't like Florida's weather, wait 5 minutes and it'll change.
But they say that in Texas too.
So one thing you have to do is draw the water cycle. So here's a short little video about the water cycle, and we'll make a chart for you guys.
Water is the fundamental ingredient for life on Earth. Looking at our Earth from space, with its vast and deep ocean, it appears as though there is an abundance of water for our use. However, only a small portion of Earth's water is accessible for our needs. How much fresh water exists and where it is stored affects us all. Nearly 2/3 of this fresh water is stored in the polar ice caps, snowpacks, and glaciers, making it inaccessible for long periods of time. The water cycle is dynamic. It describes the continuous movement of water on, above, and below the surface of the Earth, and the transitions from one state to another. Sea surface temperature, surface winds, and air temperature influence the rate of evaporation at the ocean surface. In the tropics, warm ocean surface temperatures support high rates of evaporation. Wind also increases evaporation. When the air's temperature is warmer, it can hold more water. While the atmosphere does not store a large quantity of water compared to the ocean, rivers, and lakes, it can transport water quickly from one place to another. Low-lying regions of the atmosphere with high moisture and strong winds can form atmospheric rivers to transport water horizontally. Clouds are formed as water vapor cools and condenses into droplets and ice crystals. Clouds and water vapor act as insulators in the atmosphere. Clouds help shield the Earth from the sun and trap heat from below. When cloud particles grow large enough, they may fall out as rain or snow. Under the right conditions, areas of precipitation can grow into large storms. As storms grow, they transfer heat vertically into the upper atmosphere. The migration of storms helps to distribute heat between the equator and poles, shaping wind patterns globally. How storms grow and intensify depends on atmospheric moisture, surface temperatures, and wind patterns. Precipitation is concentrated in some parts of the world and scarce in others. It can vary substantially from season to season and from year to year. Water that falls on the land surface as precipitation is stored within snowpacks, lakes, reservoirs, soils, and underground aquifers. Water availability varies from place to place and over time. The availability of water affects the type and abundance of vegetation, the primary source of food for animals and people. Extreme water cycle variability, unusually dry or wet conditions, impacts humans worldwide. Each year, hazards such as floods exact a costly economic and human toll. Most of the water that falls onto land remains stored there for weeks or more. Snowfall is stored as snowpack or ice. Meltwater and rainfall are stored in lakes and soils. Some of the water is absorbed by plant roots or drains into the water table. Eventually, the water will evaporate to the atmosphere or return to the ocean in streams and rivers, providing a source of nutrient-rich water that supports ocean life. Sensors on a suite of NASA satellites observe and measure water on land, in the ocean, and in the atmosphere. These measurements are important to understanding the availability and distribution of Earth's water, which is both vital to life and vulnerable to the impacts of climate change and a growing world population.
All right, so one of the things you have to do is draw the water cycle. So we'll give you guys a couple minutes and you want to draw basically this, and then let's label it together. So I'm not an artist, but I'd like to really see your drawing. So we'll give you just 2 minutes to draw those real quick. And then Connor and Jonathan, maybe you can turn your cameras back on so that we can see your works of art. And we'll label them together. Connor, did we lose you?
No, I'm here. My camera, I had to fix it real quick. That's why I turned off.
Oh, but we love facial reactions. So you guys have 2 minutes. But if you finish first and faster, let us know. And then we'll play a game and see how well you guys remember stuff from the video. So every answer gets you a point, and the winner will get emailed over to George to get participation points. Can you pass me the notebook, please? The notebook.
What are we supposed to do again?
So you have to draw the water cycle, which is basically this. And then as we play the game, so we saw the video and the video gave us all the answers. We'll give you a quick quiz, and everyone that you say out first that's correct, you get a point for.
And when we're finished here with the water cycle, I have one quick question to ask you, gentlemen.
And my erasable pen.
Ones I gave you aren't erasable.
I know, no nice one.
I don't know if you need those multicolors or not. I thought they'd be pretty
Oh,
good
yeah,
for you
yeah, yeah.
laying things out.
Mhm. Okay, you guys have 1 more minute. 1 more minute. Okay, guys, ready? All right. If you look, number 1, let's see. Number 1, we'll go with the laser pointer. Number 1 is right here. So it's this process right here. What would we call this process?
Evaporation.
Nice. Who said that? Connor? Nice. All right. Evaporation. We also have evaporation over here. Then we have our next cycle. Our next cycle, let me get these out of the way. Our next cycle is over here. So it's coming from the tree. Do you remember what they said coming from the tree was?
I don't remember the technical term, but it was the water from the roots is evaporating.
So the technical term is transpiration, like respiration. It's the tree breathing. So T for tree, transpiration. Did you know that some trees can lose over 105 gallons of water that way? See, Connor, that's why we wanted to have you turn on your camera so we could see your face. Love the reaction. 105 gallons that way. So 2 was transpiration. Or sorry, yeah, transpiration. Number 3 is going to be up here. So this is going from snow directly, so a solid directly to a gas. What do we call that process? Any idea? Oh. Sublimation. So it's going from that solid snow to a gas. Number 4, you've got all this water in the air. So the water's being evaporated, but it's collecting in this cloud. What do we call that?
Precipitation.
Connor, yeah, it's condensation. Good deal. We're almost there. What do we call this process where it's moving? It's going from a smaller cloud to a bigger cloud and it's moving. So if you're moving, what do we call that? You can do it in trucks, you can do it in cars, you can do it when you're taking luggage camping with Pathfinders. Starts with the, what?
It's traveling.
Yeah, but a bigger word than traveling. You're close. Starts with a T. We're going to take this from this spot and do something to this spot.
Transporting?
Yeah. Was that Jonathan? Good deal,
Yes.
Jonathan. Okay, so transportation. Okay, and now the cloud's so big and the water's so big, the wind can't keep the water up in the air anymore. So now it collects and gets heavy like his eyelids, and it starts falling out of the out of the clouds.
of
What's
his
that
head.
called? Started with the P.
Precipitation.
What?
Precipitation.
Good deal. Precipitation. All right. So we have precipitation. So we have precipitation falling here. We have frozen precipitation. What's frozen precipitation called?
Snow.
Yep, it can be snow. Okay, so now we have it just dropping on the mountain. They didn't go over that, but it's that. And then we have the water going. Let's see, where is it? Water. Oh, there it is. Number 8 is down here where it's going down into the ground. Dad, can you finish that? Yeah. Yep. Yeah.
Any ideas, gang?
Runoff.
Oh, so who else had it? I never got an email saying that he needed permission.
Yeah, I think it's what Connor said, runoff.
Ask for permission
Beg your pardon?
because it was a big file. So
Yeah, it is what Connor said, runoff. I think it's what Connor said.
It's number 8 is infiltration,
Who was doing Family Feud before? Somebody else.
Okay.
Family Feud for him. Yeah.
percolation. Who got that one? Did anybody get that one?
No.
Okay, how about number 9? We have number 9, which is here. We have number 9, which is there.
Runoff.
I honestly don't know. I can't remember. I can't recall what it is. So. Surface flow,
Okay, just 1 minute.
summer runoff. Okay, snow runoff. So you have a couple of different things, but it is basically runoff. Who got that?
Connor.
I
Connor?
did.
Okay, you got another score there. There is one particular thing on Earth that is totally different from everything else. When it turns into a solid, it weighs less than when it was in a liquid stage.
Ice.
Hmm?
Ice.
No, it turns from a solid or from a liquid to the solid and it weighs less. What is the name of that thing that converts? It's a substance. It's not ice itself. That's what it turns into, but what's it called? Water is the only thing on Earth that when it freezes or when it gets solid, it weighs less than it did as a liquid. Every other solid, when it turns from a liquid to a solid, gets heavier. Ice does not. God designed it that way because if ice fell to the bottom of the ocean, it would never melt again. But
That's pretty smart. God is pretty smart. So did you guys fill in all the answers on your sheet? Can we see it? Let's see your drawings. Hey, that's pretty good, Jonathan. Joshua, good job.
Thanks.
Can you hold it a little bit closer, Connor? Oh, those are cool series mountains. All much better than any of our drawings. Oh my goodness, you guys did awesome. So let's move this out of the way. Get rid of this and continue on. So here's another game. We have precipitation and visible precipitation. There are different types of precipitation. We've given you the first letter of each of the words. So let's see if you guys can come up with what those blanks are.
Also, take a look at the line. The line will give you an idea of how long the word is.
The line, and we'll give you a very good idea of how long the word is.
I have some.
Okay, go ahead, Connor.
So for R, rain,
Rain? You think so? Oh,
Yeah.
good deal. All right.
For the one of the S's, I want to say sleet.
Um,
I think it's the one at the bottom.
yeah.
Yeah. Snow for the other one, for the other S. Hail at the bottom.
I got do for D.
Good deal. Nice job, Joshua.
What was that, Joshua?
Yep, that was Joshua. What else do we have? 3 more to go. Let's see. Let's see what this one is. This
You
is
should get that.
fog. Yeah. What about the other F? Any last guess for the other F? Frost. And the last one is cloud. Good job, you guys. So we went over the different types of visual precipitation. What is this?
Dew,
Dew. How's it formed? How do you guys think it forms?
rainfall falling.
So it doesn't actually fall, but there's so much moisture in the air that the air just can't hold it anymore, and it ends up
Forming on a cooler
condensing.
eve.
It condenses on something that's cooler. What's this?
Fog.
Can you read the screen?
Condensation.
That's condensation. So again, there's a whole bunch of moisture in the air, and it lands on something cooler, and it condenses. Oh, what do you think this is?
Frost.
So how is that formed?
Big word.
Kind of like what we talked about here.
Condensation as well.
Yeah, so it's just like dew, only it's really cold. How cold does it have to be for this to happen?
0 degrees Fahrenheit. Or
0 degrees centigrade, 32 degrees Fahrenheit.
Fahrenheit.
Yeah, so that's frost. What's this?
Fog.
So there's still a whole bunch of moisture in the air, but the air can still hold it. It's not totally where it can't hold it anymore. It can still hold it.
Have you ever wondered how clouds form and why there are different types of clouds? Find out here in the science of clouds. Clouds appear to be solid objects floating in the sky, but in fact are a large collection of very tiny droplets of water or ice crystals. The droplets are small and light enough that they can float in the air. You can actually fit 100 million droplets into each cubic meter of air in a cloud. The most common method of a cloud forming starts with the sun. When the sun heats water from oceans, rivers, lakes, and other sources like soils and plants, some of it turns from liquid water into invisible gas called water vapor. This process is called evaporation. As gas is lighter than liquids, this causes the water vapor to rise up away from the surface. The further you move away from the surface, the cooler the temperature gets, so water vapor gas turns back into tiny particles of liquid water. This process is called condensation, which is the opposite process of evaporation. Now back to liquid. The water starts sticking to microscopic dust and salt particles that are light enough to be floating around in the atmosphere. This creates water droplets, and these water droplets hit each other to create bigger droplets and eventually form a cloud. The droplets created are very light and would fall very slowly towards the earth. They don't actually drop at this point though, as they are so light, warm air that is moving up from the earth is moving at a faster speed than the droplets can fall and pushing them up. This means the clouds gather more droplets as they ride air currents, getting denser and denser as they collide more and more until they are heavy enough to fall faster than the air can carry them up, which causes it to rain. Rain falling from clouds is known as precipitation. Also the same for snow, hail, sleet, or any other type of water that falls from the sky. This process is then repeated and is called the water cycle. There are many types of clouds. Here are some of the most common. Cumulus, probably the most recognisable cloud, meaning heap or pile in Latin. They appear like puffy cotton balls with a flat bottom that you would normally see floating by on a nice day. Stratus. Stratus means layer in Latin. They are a low, featureless, hazy cloud that blankets the sky that you would see on a grey, overcast day. When stratus is on the ground, it is known as fog. Stratocumulus, another low-level cloud, ranging in colour from white to dark grey. They often appear in lines that cover large patches of the sky with the odd break. Nimbostratus. These are low to middle stage clouds that are grey in colour and thick enough to block out the sun, often accompanied by continuous heavy rain or snow, and they cover the majority of the sky. Altostratus. Altostratus clouds are grey or blue-grey, mid-level clouds made up of ice and water. The sun can usually be seen dimly through these clouds. Altocumulus. Mid-height, white to grey, small clumps of clouds. The colour differentiates them from cirrocumulus clouds, which are smaller versions of altocumulus that are situated between 20 to 40,000 feet and are just plain white. Cirrus. A high-altitude, wispy cloud looking like silky patches in the sky that are made of ice crystals. These clouds generally appear in fair weather. Cumulonimbus.
Hold that thought.
Cumulonimbus is a dense cloud that has grown vertically. High winds often flatten the top of the cloud, so it resembles an anvil-like shape. The base will look very dark and ominous. These clouds are known as thunderstorm clouds, as they often bring bad to severe weather and carry lightning. Did you know? 7 out of the 8 planets in our solar system have atmospheres that can hold clouds. Only Mercury does not have any. Jupiter.
Hold that thought. Let's clear the. Do we have somebody drawing on the screen? Yeah, let's kind of hold off on the annotation because everybody ends up seeing the annotations and it makes it a little bit harder. So
Jupiter has 3 layers of clouds made up of ammonia, sulfur, and a mixture of ice and water. Venus, which has a pretty hellish atmosphere in general, has clouds made of highly corrosive sulfuric acid, which would not be fun to get caught in, as it melts
sulfuric
metal.
acid, that's why they said that.
The saying, on cloud 9, is generally associated with someone who is blissfully happy. But do you know where it originated from? It is believed that the saying comes from the 1896 edition of the International Cloud Atlas, which details 10 different types of clouds, with cloud 9 being cumulonimbus, which reaches up the highest of all clouds. So when you are on cloud 9, you are on top of the world. And last but not least, the water you drink every day is constantly being recycled. Once it has passed through your system, it will eventually evaporate again and become part of a cloud that will rain your water molecules back down. This process has been going on for millions of years, so the odds are that the next rain cloud you see will have water molecules that have passed through a dinosaur.
So do we believe that the world is millions of years old?
Yes.
No, scientists will say that, but we believe in creation, and creation says 6,000 years. So remember, we're all human and we're all prone to making mistakes. So when we learn, we have to make sure that we research it ourselves to make sure that what we're being told is in fact correct, and the Bible is infallible.
They took a Mount St. Helens happened in 1980. They took a rock from Mount St. Helens after the eruption, and 10, 20 years later, they took it and had it analyzed to find out how old it was. I think they come up with 600 million years or some crazy thing like this. And they said, nah, it's only 20 years or 30 years old. It came from Mount St. Helens. So the measuring devices they use assume an awful lot.
Mhm. So we learned about clouds. What kind of cloud, big, puffy, cottony cloud would you say this is?
Cumulonimbus.
It could be because there's a little gray down here. We can't see the bottom. So yeah, we would guess it's probably cumulus.
Who did that, or does he get credit?
Connor. And this is precipitation. Remember how they said how precipitation forms? So which is going to weigh more, an elephant or clouds in the sky? Which could weigh more?
Clouds in the sky.
Yep, because each gallon of water is 8 pounds, and there are lots and lots and lots. So did you know that a medium, Connor, did you know that a medium-sized cumulus cloud weighs the same as 80 elephants? 80 elephants. Isn't that crazy? Remember our barometric pressure? Remember how all that comes into play? All that weight in the air? All right. So what do you guys think this is?
Precipitation.
What kind of precipitation? Starts with an R.
Rain.
Rain. So remember, the clouds can't hold it anymore. So they just get so heavy and they drop. All right. So each raindrop is made up of millions of water molecules. And so convection comes into play that pushes the air up, and it gets so heavy that it cools it and it makes it bigger and bigger and bigger. And finally it gets so big that it just can't go on. What kind of precipitation is this called?
Snow.
Snow. So it's frozen water. So it has to be at least how cold?
-0°C, 32 degrees Fahrenheit.
Good deal. Yep. And this is actually an ice crystal or a snowflake forming. See how it's taking the moisture from the surrounding area and incorporating it into its crystalline structure? Isn't that cool? Literally, it's frozen. Isn't that wild? God is just creative. So this isn't fog. This isn't frost. This isn't snow. This is right where it's not cold enough to stay totally frozen, but not warm enough to stay all thawed. What do you guys think this is?
Is it sleet?
Good deal. Good deal, Jonathan. This, what do you think this is?
Hail.
Good deal. It's hail. Do you know that they can be the size of a pea or the size of a golf ball or even a grapefruit? And do you guys, can you think of a Bible story or someplace in the Bible where it mentions hail?
Revelations.
Revelation. Do you remember how big it was?
Ooh.
I think Joshua. In Revelation, it talks about being like what, 70 pounds?
Very heavy.
Crazy heavy. And also in one of the plagues, the 8th plague. So have you guys ever experienced hail?
I experienced
No,
it. It felt like I did.
Wow.
My mom and my sister, I think they were in New York one time, but I was a baby, so my dad stayed home with me, and they ended up having like a big hailstorm up there.
They had a huge hailstorm in the Orlando area one time, and all the cars that were parked out in the lots and everything else for sale, new ones and used ones and all, they ended up with dents in the hoods, dents in the trunks, dents in the ceiling or in the tops. It just ruined a whole bunch of cars, and it just happened to be a really bad storm that had big hailstones in it.
So remember we talked about the 8th plague? So here it is in Exodus 9, verse 18. And behold, tomorrow about this time, I will cause very heavy hail to rain down, such as has not been in Egypt since the founding until now. And that was the 8th plague. And then Connor, I think you mentioned Revelation 16:21. A great hail from heaven fell upon man, hailstone about the weight of a talent. So that's 75 to 100 pounds. So men blasphemed God because of the plagues of the hail, since that plague was exceedingly great. So 100 pounds coming from the sky. Yikes. So let's review the 4 different types of clouds. There's stratus, cumulus, cirrus, and nimbus. So you can tell how high the cloud is based on the type of cloud that it is. Can you do that? I'm getting...
Okay, the different types of clouds, if we work from the bottom to the top, we have stratus clouds in the bottom, and you can see that on the stratus. What kind of...
You want this? Whoops, sorry. It's that one.
Okay, what would you call stratus that's laying right on the ground?
Fog.
Fog, that's right. Then you have strata, it's called stratocumulus, which combination, you see it, it's long and it's flat, but it has a little puffy on top. That's stratocumulus. You have cumulus in the bottom layer, and that's just, in aviation, we used to call that popcorn. Then you start getting into nimbostratus, which is low clouds, but you can see it right there. Nimbostratus, what does nimbo mean? Cumulonimbus, that's this big one over here. What does it do? There's what falling out of it?
Rain.
That's right. So nimbostratus would be rain cloud, but a big one that would be raining all over the whole area. These clouds over here on the right, cumulonimbus, would be thunderstorms. They would be spotty. Then you have in the 6,500 foot area up, you have the altocumulus. Now notice the difference. This is stratus, nimbostratus. It's all called stratocumulus, cumulus. Now alto has the name altocumulus.
Because it's middle.
Altostratus, that's the middle clouds, okay?
And cirrus is seriously high.
That is getting up there, above 23,000 feet. But cirrostratus, you see the sun with a circle around it. Cirrocumulus, which are the little puffy ones, but that's called a mackerel sky or a fish belly sky. Cirrus, and then this cloud over here goes even above the cirrus because it's building at such a rapid rate that it doesn't get a chance to cool, and the hotter it gets in comparison with the outside temperature, the faster it moves up, which makes it a very, very dangerous cloud.
So one of the things you guys are going to need to do is you're going to need to document the weather twice a day, 12 hours apart for a week. So you're going to need to also notate what kind of clouds there are, because the clouds kind of also forecast the weather. So these are stratus clouds, and they're not usually going to bring rain, but they're going to possibly bring fog. So those are stratus. So he kind of went over the clouds. So which of these are stratus clouds? Which are these are stratus clouds? Where do you think?
The one that's like at the bottom, the second one.
This one?
Yes.
All right. Whoops. So these are the stratus. You have the altostratus, you have the stratus, stratocumulus. So you were right. You've got all these different cirrostratus. And so these are going to be cumulus clouds. And these are your cumulus clouds.
The third one in the bottom.
Mm-hmm.
Who was that?
I don't know. So you have the cirrocumulus, alto. So see how the names kind of help you identify where and what, and they're going to be the big white puffy clouds. And what about this? These are going to be the high wispy, really, really high clouds, and it's going to be cold. Cold clouds, way up high.
Those are ice crystals.
Yep. And they're usually, when you see this kind of weather, it's usually fair weather, usually good weather. And then there's going to be 3 of these cirrus clouds, and they're all really high. So you're never going to see cirrus clouds below 23,000 feet.
No rain.
And nimbus means, what do you think is going to happen here? You can kind of see off rain. So when you have those nimbus clouds, they're going to be like thunderclaps, thunder clouds, all different kinds, but it's going to bring rain, and that's serious rain. Yeah. So here are your cumulonimbus, and you also have your you can't see, it's hidden behind here, but your anvil top. So those are all your clouds. So you're going to want to make sure that you notate the clouds so that you can kind of start learning what the clouds do in forecasting the weather. So what kind of cloud was this again?
Nimbus.
Okay, cumulonimbus. Is this going to be, what type of weather is this going to be associated with?
Thunderstorm.
Thundery.
Good. Barometric pressure. Are we going to have a low barometric pressure, or is it going to be a high barometric pressure?
A low one.
You guys are good. Now we're going to talk about lightning. I know. Get ready. It's going to be shocking.
I saw you caught that, Connor.
So these are going to be the basic types of lightning that we're going to talk about, and we're going to actually get to see them. It's pretty cool. We're going to get to see a tree explode too.
Whether it's up in the sky during a thunderstorm or helping send a DeLorean back to the future, lightning is a beautiful, dangerous phenomenon. Most people picture lightning as a brilliant white strike that flashes between a cloud and the ground, but there's also lightning within clouds and between clouds. Plus, there's colored lightning and even glowing ball lightning. It's all about a buildup of electric charge and the release of that energy in a bright flash. To have a lightning strike, you first need to separate positive and negative charges within a cloud. Clouds are essentially a bunch of really small, dust-borne ice crystals and water molecules. During a storm, the air is moving around and making these particles collide. So one theory is that some negatively charged electrons from the upward-moving water molecules get transferred to the downward-moving heavier particles. This makes the bottom of the storm cloud more negatively charged and the top of the storm cloud more positively charged. And remember, like charges repel each other. So the electrons near the Earth's surface are repelled away, and the ground underneath the cloud is left with an overall positive charge. All this charge separation creates a strong electric field between the ground and the cloud. Basically, an electric field describes how much force and in what direction a positive charge would go if it were in the field, in this case, upward toward the cloud. And when the difference in charges builds up enough, the first stage of lightning begins. Most of the time, we see negative lightning. This is when the electric field grows strong enough that an invisible channel of negative charges, called a stepped leader, begins to branch toward the ground at about 50 meters per microsecond. Meanwhile, an upward-moving channel of positive charges, called a streamer, rises up. They meet with a huge bright flash that travels up. Not to mention imagine the heat over 25,000 degrees Celsius, which is about 5 times hotter than the surface of the sun. Because the negatively charged electrons stream from the cloud down to the ground, it's called negative lightning. There's also the much less common positive lightning, with a net transfer of positive charge from the cloud to the ground instead. These strikes start at the top of a cloud where positive charges hang out, so they need to travel through much more air to reach the ground. So they need even more charge separation, which means the strikes can be up to 10 times stronger than negative lightning. In fact, these strikes can even break apart molecules in the atmosphere into ions, which can collide with other molecules like hydrogen and oxygen and cause photons of red light to be released. If this happens, we call them red sprites. They usually only last milliseconds and can kind of look like giant jellyfish in the sky. And if that sounds cool, there's another type of lightning called a blue jet. This lightning occurs when large amounts of positive charge stream upward in order to neutralize the charge in the cloud. The blue jets can get up to 40 kilometers high, but only last for fractions of a second. And scientists believe their blue color comes from ionized nitrogen molecules. Even weirder is ball lightning, a glowing grapefruit-sized ball of gas that lasts up to 20 seconds. But scientists aren't quite sure what causes it. One theory suggests that ball lightning is caused by ions made by a lightning strike near glass, like a window. The ions could pile up on one side of the glass and create an electric field, exciting air molecules on the other side, which would release photons and create a glow. Another theory suggests that elements in soil are to blame. In 2012, scientists in China recorded the first video of ball lightning. They monitored the light it emitted and found that it contained silicon, iron, and calcium, which are all elements found in soil. So a cloud-to-ground lightning strike might vaporize the soil's silicate compounds, which react with the surrounding atmosphere to produce a ball of light. So the next time you're watching a thunderstorm from the warm, dry safety of your home, remember that all this lightning has a lot of physics behind it. Beautiful, dangerous physics.
All right, let's see some lightning. So remember, you have the lightning positive at the top, negative at the bottom, and opposites attract.
It begins as a small spark inside the cloud 5 miles
Let's
up.
see.
Lightning will strike anything that stands high above the ground. Trees are a favorite target. Lightning runs through the tree's sap, instantly vaporizing.
Cool, right?
A strip of bark can explode like wooden shrapnel and travel outward at lethal speeds.
So do you want to be by trees when there's lightning in the area?
No.
Pretty slick, huh? So clouds. These are different types. Remember, he talked about blue jets and sprites and gigantic jets, bolt from out of the blue, like blue sky. Somebody's out on the golf course and all of a sudden they get struck by lightning, not a cloud in the sky. That's how it happens. Bolt from the blue. You have spider, where it branches out like spider webs. You have beaded, where it looks like little tiny balls that are connected. There's forked, there's ribbon, where it comes out in literally ribbon shapes. It's pretty cool. Ball lightning, let's see a couple more. So here's lightning bolt from the blue. And here's spider bolt, because it looks like a spider web.
Oh, that's cool.
Beaded, see how it looks like little tiny balls that are all connected. Forked, because it has a whole bunch of different breaks in it. Ribbon, slick, huh? Here's our ball size lightning. So it's going to go in slow motion again, so you can see it again.
Oh wow, that's cool.
It's so small.
Mm-hmm.
So cool.
I don't know why it's so small.
It just like hits right there at the bottom.
So we're going to watch the video again, And let's count. Oh, see it's forming. It's just a little ball. It's just crazy. So we're going to listen to, we're gonna see the flash and we're gonna start counting seconds. Do you know how many seconds per mile it is? So they say anywhere between 5 and 3 seconds, but we'll go with 5. So here we go. We're going to see the flash, and then we're going to count how many seconds and figure out how many miles away it is. You ready? What did you guys get? How many seconds?
I got between
9.
7 and 8.
Yeah, same.
I got like 7 and 8.
9.
So that's just over 1.5 miles to 2 miles. Isn't that cool?
Wow.
So here's your energetic narrow bipolar event. There's your red sprite. They can see these from the space station. You've got your gigantic blue jet, and look at it go. And it's just fractions of a second. So here are the crazy ones that they were talking about that you can see up in the upper atmosphere. So if you guys become astronauts, there you go. You can see these. So we're going to talk about some safety tips to avoid getting hit by lightning. Wait. There we go.
First of all, contrary to popular belief, we're not all the same. I mean, you got Stratus, you got Cirrus, you got Fractus. Love saying that one. Contrails are not clouds. They wish they were. Yeah. Fog is a part of the family, but we don't necessarily like to talk about him. Is the camera rolling on this? I am a cumulonimbus. I am a storm cloud. You know, I don't know what everyone else does for excitement, but for me, lightning. Pow! Zap! Rain? But lightning is my jam. I don't tell just anyone this, because everyone thinks I'm such a good shot, but, you know, I have enough voltage that I don't have to hit exactly what I'm aiming for. Most of the time, you know, I just get close and the ground current does the rest. I love surprising people, you know? Like, I hear people say, oh, lightning's coming. Let's get under a tree. Well, I hate to tell you this, but I'll just hit the top of the tree. It goes down the trunk and bam, you're done. You know, or people will say, oh, no, get into an open field. Well, guess what? You know, all I have to do is get close, especially if they stand with their feet apart. You know, it goes up one leg, down the other. So, you know, the further their feet are apart, the stronger the jolt. The biggest surprise, though, comes where people lying on the ground. They think they're safe down there, but it's just like a pretty easy target. Like, there you are. But, you know, if they stand with their feet close together, they stand more of a chance. And, you know, you win some and you lose some. You know, once I was working up in this big storm over the Targies, you know, and there's these campers down off to the side, and the girl was doing the classic thing of, you know, counting 1, 1,000, 2, 1,000, 3, 1,000. But, you know, guess what? I was 10 miles away, and I still got them. Slam dunk. You know, that is well, they were in a car, so they were fine, but still a story. You're gonna be telling your grand clouds that story. Sometimes people make it a lot easier for me to hit them. I mean, they'll go stand next to like a power pole or a tree or metal. I mean, come on, people, metal? It's conductive. They'll get next to water, a swimming pool, or like a pond, and like stick their fishing pole in. It's like, hello? Cherry on top. My grandpa, actually, he got this one guy. He had a chain attached to a kite. It's like, you know, my grandpa still tells that story, but that guy was asking for it. Sometimes I feel like it's too easy. You know, I have a bit of a moral conundrum there. Should I even? I've been to support groups. I have cloud counseling. Oh, sure, there's tough targets out there. There seem to be these people who have me all figured out, which is frustrating. You know, like they'll get in their car and just drive away. Or, you know, or they'll get in their car and just wait for me to pass by, and I can't get them. I can't get to them. You know, they make sure they're not lying in a field or standing next to their friends. I mean, stand next to your friend, that's a 2-for-1. I'd love to get one of those. Then they make sure they're not the tallest object out there. You know, they don't stand next to a tree, or they go inside a building. But, you know, I can't wait around all day. I got some easy targets to strike. My name is Sam Cloud. I love floating around. I have a silver lining. I love making lightning. I love hitting easy targets. I'm a cumulonimbus, and I'm a storm
Hello? Hello? All right. So we did the distance practice already. Volcanoes. How do you think volcanoes are going to affect the weather? What do you guys think?
It puts like massive amounts of smoke into the air.
Okay. So what's that going to do? Is it going to make it hotter or cooler?
Hotter. Well, cooler because it's going into the air.
Okay. So, Dad, can you do this? Oh. Yeah, so it's going to be cooler because you have that cloud coverage. It's going to have more particles in the air. So remember how water droplets form? What it takes forming around some particle. So do you think it's going to rain more or less?
I want to say more.
Yeah, it could rain more. What about the sun? The sun is trying to send energy. What's going to happen when it sends the rays and it hits the cloud? Do you think they're going to bounce back and be deflected, or do you think they're going to go through that cloud?
It's going to deflect it.
Yep. So volcanoes have been known to change the temperature of the world by a few degrees. So it's pretty cool. So you've got that volcanic ash, the debris blocks out the sunlight and cools the temperature. The change in temperature, it's going to change the winds and the jet stream patterns. You can have heavy rains and heavy snows. So, sun and the seasons. The sun also affects the seasons on the way it's shining on the earth. So the angle of the earth and the sun is going to change summer and winter. So if it's hitting us more directly in the northern hemisphere, is it going to be hotter for us or cooler?
Cooler.
So right up here.
Hotter.
Okay. So it's going to be hotter here. Dad, can you? Sorry.
Yeah, no problem. Okay. We have different belts. Let me change this a little bit. You have the different belts. You have the North Pole, right? You have the Arctic Circle. You have Tropic of Cancer. That's this one on the northern hemisphere. You have the equator dividing the north from the south. You have Tropic of Cancer. That's this one right here. You have the Arctic Circle, and then you have the South Pole. Now, what does the Tropic of Cancer and the Tropic of Capricorn have in common? That is the line that goes around the world of the northernmost point that the sun hits the earth at a 90-degree angle. Okay? So that's summer for the north, and when the 23.5 degrees tilt, when it gets on the other side of the sun, then it's summer for the southern hemisphere. We have the angle of the sun, which does affect the temperature of the earth at this time. What are we going through right now? This is called, well, not going through it that well here in Florida, but it's called autumn, right? That means that what's happening? The earth is rotating around the sun, which means that the angle that the sun hits the earth is changing. And it's gradually going down to where it's going to hit the equator 90 degrees straight on, and then it's going to hit the Tropic of Cancer. It's going to get all the way down and have a Tropic of Capricorn, so that it's summertime in the southern atmosphere, southern hemisphere, which is the Australia. I'm not going to get into whether or not Australia is upside down or we're upside down. That's a discussion for another day. That was supposed to be humorous too, by the way. And we'll go to the next thing here. This shows you the view. Okay, June 21st, about June 21st, right in that area is the when the sun is vertical to the northern hemisphere. Okay. Now, the opposite, 180 degrees out, is when it's on the bottom hemisphere, what we call it the bottom, the southern hemisphere. And that's when it would be exactly 90 degrees to the Tropic of Cancer. That's December the 21st, which happened to be my sister's birthday, by the way. Any questions? That's how the seasons are handled. We go through summer, winter, spring, and fall, whichever way you want to call it. And the earth moving around the sun changes the seasons. It's just in a nutshell. And God said that the earth should tilt 23.5 degrees, and it gives us the best of both worlds.
You guys are doing awesome. You're pulling through. He kind of went over this already with the solstice. Here's how to forecast weather. We talked about how you can forecast weather with clouds. You can look in a rainbow, so you know that the sun has to be behind you and the moisture has to be in front of you. You can look at the moon and how bright it is, or if it has like that halo around it, the wind. Animals even tell you what's going on. So like ants will build their homes taller and higher when it's going to storm. Birds fly lower and catch more bugs before storms. Turtles go for higher ground. Cows, they say, lay down. Cats start licking behind their ears. Oh, my cat just wanted to come over now. All different kinds. Nature is incredible. Fires, the smoke is lower when it's going to be stormy. It doesn't rise up as much because remember, hot air rises, and that would be clear, anyways, that would be clear columns going straight up, but this is getting stuck. There's more humidity, all different kinds of things. So now I have a challenge for you guys. You're supposed to chart the weather. You need to do it for 1 week. And you need to do it twice a day. And you need to get the temperature, the moisture, the kind of cloud formations, wind directions. If it rains, you can chart the precipitation and all that. And you'll show that to your director. You also, here's another chart. You can make the chart any way you want. Be as creative as you'd like. So this is your chart. Be creative, knock it out of the park, and show your director how creative you are. You also need to make a weather instrument. Now they suggest a wind vane or a weather vane, and another suggestion is maybe a rain gauge. But you guys can be creative, and you can make something like a barometer with a jar and a balloon. There's all different kinds of things that you can do. So look online, check out YouTube videos, find something that you're going to be excited about doing. And so chart the weather, show that to your director with your weather instrument that you make, and see how that turns out. The last challenge, we have a couple minutes and then we'll let you guys go. I'd like you guys to search on the internet and see if you can find or determine the temperature based on crickets. Let's see who can find out from the internet how you tell the temperature based on crickets. Are you guys ready? On your mark, get set, go.
Found it.
Okay, what did you learn?
The frequency of cricking varies according to temperature. To get a rough estimate of the temperature in degrees Fahrenheit, count the number of cricks in 15 seconds and then add 37. The number you get will be an approximation of the outside temperature.
So did they give a cricket or any chirping sounds or anything that we can listen to and see if we can tell? Okay, so we count for 15 seconds, right? You said count for 15.
Yeah, then you add 37.
Then we add 37. Okay, second challenge. Let's see who can find cricket chirpings on the internet, maybe YouTube.
Found it.
Okay, go ahead. Can you play it for us? Okay, so we're all gonna have to listen, and I'll start the timer when you're ready.
Okay, how do I do it? Do I share or?
We can, let's see. Let's make you. And make. Okay, Connor, your co-host. Go for it.
Okay, can you see it?
Yes. Okay, so on your call, Connor, you tell me when to start the timer.
Okay, ready? 3, 2, 1, go.
Okay, stop. What did you guys get?
I couldn't hear.
So I got about 32.
I got 34.
So you were pretty close. What did you get, Joshua?
I couldn't hear.
It was hard to hear.
Yeah.
So you counted for 15 seconds, and let's go with 34. And then we add what, 37 to it? So 34 and 37 would be
71.
Yeah, 71.
71 degrees. So when you go camping with Pathfinders and you hear those crickets chirping, you can start counting and you can figure out the temperature. Of course, in Florida, it's usually hot. That's the answer. So we hope you guys had fun. Do you have any questions before we have prayer and sign off?
I do have questions because there were some things I didn't catch. That's great. Can you hear me?
Okay, yes.
So there were some things I didn't
You Josh.
Yeah.
down. So how does hail form?
How does we hear paper moving and it's hard to hear you?
One of them was how is hail form? How does hail form?
Oh, okay. So hail, you have convection. So the wind is blowing up. So it's blowing up the moist air and the water droplets that are forming. So it goes up and it cools. And then as it cools, it gets heavier because it gets bigger and heavier. So it starts to fall. And as it falls, the wind, it gets to a point, so it starts melting a little bit. And then the wind sends it up again and it freezes a little bit more. So it goes back and forth, getting bigger and heavier until it gets so big and heavy that the wind, that the upward air currents can't keep it up anymore. And it falls so fast that it doesn't have time. And also the temperature is such that it doesn't have time to melt before it hits the ground, right?
Right.
Sound good?
Yes.
What else?
With the seasons, this is the last one. So seasons, I can't tell what do I draw for autumn and spring?
Okay, so autumn and spring, we can go back. I'm going to go back to sharing. Okay, so over here, you have March and you have September. So this is autumn over here, and this is spring over here. So basically, the sun is hitting directly on the equator. So there's an even balance above and below the equator. So that's why it's not too hot and it's not too cold. It's just right, that Goldilocks spot.
Autumn, of course, going into winter, and
spring coming out of
winter, going into summer.
Mm-hmm. So did you guys learn anything? Did you have any fun? What are you going to make, Joshua? What kind of weather instrument do you think you're going to make?
I was thinking of making the wind vane because it would help with the chart, and also it just seems fun to make since we don't have one in our house.
Good idea. What about you, Connor? What are you going to make?
Probably the what Joshua picked, because it actually looks really cool, and I would love to like see it like spin and like it look like really blurry. So
okay. Jonathan, what are you going to make? Uh-oh. Did we lose Jonathan? Oh, well. Anyways, do we have any volunteer for closing prayer before we go?
I'll pray.
Okay, thanks, Connor.
Dear Heavenly Father, thank you for this day. Thank you for allowing us to be able to learn about your creation and how the earth works. Thank you for allowing us to come together and be able to have this opportunity to learn more. Thank you for enlightening us on how different parts of the earth work and how they move and cooperate together. Thank you for allowing us to have a great Sabbath. In Jesus' name I pray. Amen.
Amen. Have you guys been having fun at Camporee?
Yeah.
What was your favorite part so far?
Here,
Besides this one. Besides this
one. Probably the activities, a lot of activities that we have to do.
Okay, so which activities have you done?
I did the Jeopardy, and then I did Bible charades.
Nice. Which column of Jeopardy did you like the best?
I kind of liked all of them, to be honest. Yeah, because some of them were easy to me and some of them were hard, but I still liked it.
Good deal. What about you, Joshua? Have you gotten to do any activities yet?
I only did another honor earlier.
Oh, what did you take?
Parrots and cockatoos.
Oh, did you like it?
Yeah.
What did you learn?
I learned a lot. Like most of there are only 21 cockatoo species, and 14 of them live in Australia, and that a lot of them are endangered, and that there are none native to Florida.
I
also learned about like how some parrots have like brushed tongues because they only drink nectar and flower pollen.
Yeah, I thought that was amazing
I thought
too.
that was neat too. Yeah, that was really.
And the really expensive one, that gray one.
Yeah.
Wow. And Jonathan helped us by teaching a shark honor. So thank you, Jonathan. You did awesome.
Thank you.
So guys, go enjoy the rest of Camporee. Maybe you can get in some activities, and we'll see you tonight. Thanks. Bye, guys.
Bye.
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 Here's the totals.
Mm-hmm.